This is the second episode of the GitHub Actions course, and today we're going to be talking about continuous integration. If you're new to GitHub Actions, stop right now, go watch the first video in the series, and then come back to this one, because I'm going to assume that you are already familiar with the basics, and I'm not going to cover them again now. Also, this video is not your average tutorial. If you are looking for a quick fix or like a short introduction to how to use GitHub Actions, there are plenty of other channels that do that. Here, we're going to be discussing the why, the history, and the fundamentals so that you are always able to discern the signal from the noise. I want to enable you with the fundamental information so that you can utilize this knowledge in your projects or even at work without coming back to these videos for step-by-step instructions. This series is a bit lengthy and they're packed with information. Today, we're going to be covering how integration was done in the past without automation, what problems continuous integration aims to solve, how do popular projects like cPython, yes, the Python interpreter, do continuous integration with GitHub Actions, and lastly, we're going to be doing a short demo for a continuous integration workflow for a NodeJS app. Let's get started. Before we talk about continuous integration with GitHub Actions, we need to discuss a little bit the history so that we can cover the fundamentals of why continuous integration is important. And in order for us to understand this, we need to go back a little bit in time and show you how the process was like before the concepts of continuous integration were introduced. So previously, people used to use, or developers, or large development teams used to use obviously some form of source code management solution. It doesn't necessarily need to be Git, right? So previously people used Clearcase or Perforce or the SVN, and people still use SVN until this day, right? And there are so many other options for source code management. But besides that point, the principle of integration applied irrespective of the tool that was used to manage and track source code changes, right? So the way to represent this is, let's say we had a project and that project was contained in one or more repositories. But for the simplicity of the scenario, which is going to tackle one repository, right? And we had one or multiple developers who were probably on the same team or in different teams, doesn't really matter, right? So these are the developers, boys and girls, let's say, and we have one repository and each developer was creating their features in a feature branch, right? So also let's simplify it and let's say we had the concept of feature branches available, right? It doesn't necessarily need to be feature branches. Different source code management solutions rely on different principles. But again, fundamentally, it's all the same, right? So let's say in this case, we had 4 developers and they all had 4 feature branches. And all of these feature branches belong basically to the same repository, right? So I hope this picture is a bit clear and sorry for the horrible handwriting. Once these features were completed based on a certain development cycle, this development cycle was usually stretched for weeks and not necessarily like we do today over a period of a week or 2 at max. These development cycles were stretched over probably months, even quarters. So imagine for an entire quarter, the team would be working on building an entire set of features. And the only way these people were able to check whether their features worked, right? Whether their features worked in the grand scheme of things is for the integration team to come in and combine all of their works into one gigantic executable. Well, it doesn't have to be gigantic, right? But I'm taking the example of a large piece of software because obviously it becomes much more difficult in that case. So the integration team could be composed of one or multiple individuals. These don't necessarily need to be, they need to be technical, obviously, right? So they probably developers, but they are more concerned with the integration effort. And then this integration team will pick these feature branches, right? And they will manually integrate all of them. So the way you would see this is by, let's say they have access to a large machine, and that machine will, they will check out the repository, and then they will check out each individual branch on that machine, right? And then they will run smoke tests. And smoke tests are basically just quick tests that allows them to verify that the code after integration builds, right? And the second thing is that it runs. So the outcome of the integration team was to make sure that the application builds and that it runs after the build is successful. Their job is not to test whether these features are according to the spec or to the design. The integration team will then hand over the project or the code base to the quality assurance team. And the job of the quality assurance team is to verify that the features meet the spec and business requirements, right? That's their job. Once they do this verification, right, if they find problems, they need to send back this whole set back to the developers, and then they need to start the whole process all over again, right? And you can imagine if this process happens once every a few weeks, or once every month, or even worse, once every quarter, this effort, this loop will take probably weeks to complete, right? And can you imagine if during these weeks, new features are also being introduced? It was a nightmare, to be honest. And this is why continuous integration gained a lot of traction and became quite mainstream. So now you've seen how things were done before. Now we're going to talk about how this whole thing is sped up so that people can actually do this integration, testing, and merging with the main branch in a matter of hours, right? As opposed to weeks or days or quarters or months. Now that we've discussed the old way, let's discuss how things are done in the modern world, right? We're not going to change the example. We're still going to assume that we have a single repository that contains our source code. And we are going to assume that the SCM solution that we are choosing has some automation capabilities. Or if we don't want, if the SCM solution we're using does not have that, we could use third-party tools, right, that will allow us to do so. But it would be nice for us to have first-party tools. Why? Because this means that the whole process is contained within the same application, and we don't have to switch contexts, right, whenever we want to do different things. So this repository obviously has multiple people as well. Same team or different teams, doesn't really matter, contributing to it. And again, same principle of feature branches, right? Obviously, the branching strategy will definitely affect heavily how we do continuous integration. However, we're not going to discuss that right now. We might as well have another video to discuss branching strategies. Now, with the feature branches in place, our code, if we're going to visualize this in a different way, let's say we have the main line, right, which is probably our master main branch, master main, whatever you want to call it. So let's say this is the main branch, and then if someone wants to introduce a feature, they will basically create a feature branch right here, and then they will introduce their first change, probably introduce the second change, right? And then when they are, and then the main line will obviously continue. And let's say someone else is also picking up another feature, so they could potentially create a branch from this point, right? And then they could introduce their feature over here, and then their feature here. Now the question becomes, how do we merge back these changes from these two branches, right, back to the main line? And this is the whole purpose of continuous integration. So first things first, some of the principles that we need to put in place for continuous integration to work is, number one, automating the build, right? if we cannot automate the build process, and if we still need some manual intervention in order to build the tool or the application or the software, we fail. If we don't have a build, we cannot test. If we cannot test, we cannot do continuous integration, right? So that's step number one. Automating the build is as simple as taking the commands that we used to do or run manually and just putting them in a small script, right? And then just simply telling the CI solution to execute these scripts, right, or these commands. So first of all, we need to automate the build. Second of all, we need to introduce tests, automated tests, right? This is important. It doesn't really matter whether you use test-driven development or not. What matters is you have different types of tests, and depending on your application, you might want to, at the minimum, you need to have unit tests at the very least, right? And then next step, you would want to have some integration tests, especially if your application is complicated and it really integrates with different services. You would definitely want to test these things, right? And then you could have also different varieties of tests, like UI tests, and even automating how the UI is being tested with the automation of the, like Selenium and things like that. The third thing you need to introduce is probably linting. And linting is important because you want to maintain a unified coding style across your code base, right? And you don't want things to have really weird coding style in different places of your code base. And 4 is something also optional, but I really prefer it, is to do some form of security checks, right? And security scanning, this is important. Why? Because the earlier you discover security problems, the higher the probability of fixing them, right? So if you delay this step towards the very end, then the chances of your team fixing these security problems will be drastically reduced, mostly because we are gonna repeat what's happening here, right? The cycle is gonna be really, really long. So in order for us to increase the chances of the teams fixing their problems as early as possible, we need to introduce these tests as early as possible. Now, what happens is that whenever we want to merge a certain feature branch back to the main branch, what happens is we need to create a pull request. And this is assuming that we are adopting the GitHub flow or GitHub workflow or GitHub way of working. Once we create the pull request, the CI solution will basically trigger the different automated steps, right? And will ask them to run. And then the results of these will be reported back in the view, right, of the pull request, so that the developer and the team working on this project can see the outcome of their feature, right? So when we say automate the build, in the pull request, we are gonna build the application using the new features that were introduced. And if the build fails, that means there's a problem with these features and the developer needs to reiterate. But instead of reiterating on the entire cycle with all of the other feature branches, their iteration is localized only to their feature branch. Now, once they fix the problems, they can obviously introduce fixes here in the yellow, let's say, and then the automated tests will run one more time whenever we commit new changes, until the changes are successful or until all the tests are successful, right? So the build will run. Next step will be running the automated tests, whether they are unit tests, integration tests, whatever they are. Linting happens, the source code style needs to be verified, security and scanning needs to happen, and in this case, if there are vulnerabilities that are discovered, the developer needs to go back and introduce new fixes, right, until the checks pass. Now, once we do all of these things, we can have an optional step. We can say that we need to do extra verification for this feature, and in order for us to do that, I would want this pull request to be, for example, deployed, right, to a staging environment. This is where extra quality assurance work can be done. And then if we find problems here, we can again go back to the PR, just like we did here, and repeat these steps and introduce the fixes on the feature level. Once we complete all of these things, the tests have passed and the source code was reviewed by peers, right? Then we can automate, oops, sorry about that. Then we can automate the process of also merging the pull request back with the main line, right? Merging it back with the main line. And then whenever we merge back with the main line, what do we want to do? We want to run the same tests one more time. And you would say, oh, why are we running the tests a lot? Yes, that's the purpose of continuous integration. We want to, at every single step in time, with every single change that we introduce, retest the entire code base to make sure that we did not introduce problems. And this will give us the sufficient confidence that what we are doing is moving in the right direction. Once we merge back with the main line and the CI tests have succeeded, we know for a fact that our changes are good to go, right? Obviously, bugs might still creep in because no matter how many automated tests we introduce, they cannot cover the entire complexity of the application, and this complexity obviously grows as we grow with as the source code grows and as the complexity of what we're building grows, and as the number of people introducing changes to the application grows. But with automation, we are able to have a higher level of confidence than doing all of this work manually, right? Because we are doing it as frequently as we can and at every single change that we introduce. Now, whenever someone else wants to introduce a feature following the introduction of our changes, what will happen? Here, the tests will run on the level of the pull request itself, right? So the tests will only verify that these changes here, starting from this point over here, right, are okay. But this is why the testing on the main line again, once the PR is merged, is important. Why? Because once we merge this PR over here, we want to test again, because now the step here, right, should verify that these changes plus these changes, right, are correct. And this is why continuous integration is awesome, because now we don't have to go back to this horrible loop of asking the integrators to one more time integrate everything manually, right? The CI automated tests will take care of that, because here we are building again, we are running the tests again, we are linting again, and we are running the security scanning one more time just to verify that everything here is going well, right? And once we merge with the main line, we can then create a release from this point over here, or we can create it from any point before that or after that. Why? Because we are always sure that the points that we have on the main line are working. They can build, they can run, and they are correct, right? As far as correctness goes in these situations. An important part of studying any topic, and more specifically software engineering, right, is looking at how the more experienced engineers do it. And there is no better way than looking at open source code, and more importantly at popular open source projects. So in order for us to see how popular projects do continuous integration, I'm gonna actually look at the cPython project, and I'm gonna look at their GitHub action implementation to show you how this project does continuous integration. Whatever you're gonna see now is not gonna be very different than what I just showed you from a theoretical standpoint, but let's go into the workflow right now and dig into the details and see what's going on here. So in order for me to do this, I'm gonna launch my browser. I'm just gonna put it here to the side. And what I'm gonna do next is I'm gonna take this and I'm gonna add it to my notebook. And this will allow me to create a small snippet of the workflow, right? Which we can then annotate. And this is what I would like to do over here, because I wanna add some notes and discuss with you what's happening in each step of the way, right? So we're gonna move this a little bit here. This is the cPython project. As you can see, it's on GitHub. You've seen the URL. You can just go there, and we can go into the .github folder, workflows, and then we can look at their build.yaml file, right? Once we have access to the build.yaml file, we can start looking at the YAML file here, and we can start looking at the syntax for us to try to decipher or understand how these folks are doing continuous integration. So first things first, we're gonna name the workflow. And if you are confused about what you're seeing on the screen right now and you don't know what's going on, I highly recommend that you watch the first video in the series where I explain the workflow syntax and how we can run and trigger workflows in GitHub Actions. So go ahead, check out that video, and then come back here once you have a good understanding of the workflow syntax. So again, first of all, we start with naming our workflow, and then we need to define based on which events does our workflow run. So the first event is the workflow dispatch, which means they have to click a button in the UI to run this workflow, because obviously they want to be able to run these tests and the builds on demand whenever they need to. And then the second event is whenever a push is done on one of these branches, so either on the main branch or the current versions that they are supporting, right? And as you can see here, they are adopting sort of a long-term branch strategy, which is fine. It's understandable for projects like this because they need to maintain long-term support for certain languages, or even they need to maintain older versions of the project, right? And then the third event is pull requests, whenever a pull request is created against, again, one of these branches. So this workflow and all of the jobs in it will run every time we either click on the button, or we introduce a push to any of these branches, or we create a pull request with any of these branches. And the push event over here, just also to connect this to what we discussed previously, the push event over here will allow you to basically run the tests at this level, right? And then the pull request over here will allow you to run the tests at this level over here. And this is how we connect what I just described with a clear-cut example from the field for how CI is done, right? So this is the first step. Next step is to, let me edit the clip, and let me take on another section, and let's start going deeper into the jobs so that we see what's really going on here. Let me delete all of this stuff over here. And let's go into the details of what's going on. Obviously, the jobs are gonna be probably a little bit more complex than your normal project, because this is an entire interpreter for a language, right? So there are many things that need to happen here beyond a simple project. Now, the first job that's running in this workflow is called check source, right? And then this job runs on Ubuntu latest, the latest version of Ubuntu. And it has two outputs, which are run tests and run SSL tests. And I think they have this job to check basically what are the changes and determine whether they need to run the tests based on these changes or not, right? So the first step in this job is for them to check out the repository. And when they do that, they are running a number of shell commands, as you can see here with the run. And if you add the pipe, you will be able to add a multi-line shell script that you can execute. So first of all, they are checking whether the GitHub base ref is empty or not. And if it is empty, they are setting these values to true. And then the next step is that they will, otherwise, they will fetch this branch from the origin, and then they are gonna try to do a git diff, and based on the outcome of that, and they are doing some a grep on some of the values that come from the git diff, and they are trying to determine whether they need to run the tests by setting the output of these two variables to true, or keep them to the default, which is empty, and then the tests will not run in the next steps, as you will see here in the check generated file. This is the next step that they go through. Again, it runs on Ubuntu latest. It needs check source. This is not something that we have seen before. So as I told you in the previous video, or in the first video I referenced earlier, is that jobs can run in parallel, right? So jobs can run while other jobs are running, and each one of them will be run on a separate runner, which is completely independent from the other runner. However, when we say that a job needs another job, the check generated files job will not run until the check source job has been completed, and more importantly, completed successfully, right? Why is this necessary? Because this job here introduces a conditional, which is the if, and the if says if the output of the check source job is true, right, then run this test. Otherwise, this test will not run. So one more time, we're gonna switch gear and get the next segments of this file. So let me remove all of this stuff. And we're gonna edit the clip one more time, and we're gonna scroll down a little bit. Obviously, I'm not gonna go through all of these different jobs because it really doesn't, I think we can get the point across without having to go through the different nitty-gritty details. I just want to make sure that you get the most out of the what we're seeing right here. We're not going to try to decipher the whole pipeline because obviously it's very specific to the cPython project's needs. I just want to show you what is possible here, right? So next step is to check the, again, check generated files job. We talked about the condition over here. And then if the condition is true, we run through the list of these steps. And as you can see here, it's quite a number of steps. So first of all, we check it out. Next thing we do is we need to install Python. We need to set up Python. They don't specify here really which version of Python they want to set up. So I'm assuming there's a default value for probably, it might pick up the latest version if they don't specify it, but I'm not 100% sure. We can check that later. Next step is for them to, as they say, install the dependencies, and they obviously do that by running this shell script that is provided in the workflows folder. And then they do the build, right? So we discussed before, building is a major important step in your continuous integration workflow. And obviously the build steps vary from project to another, but this seems to be the way you can build the cPython project, right? They are obviously using make, and they are passing some parameters to it or variables. Next step is for them to check for some changes. I'm not sure why they're doing this right here. So yeah, I'm not gonna comment on this one. And then they check the libpython symbols. They also have another make script that they are running. They seem to be relying on make a lot, which is great, which is fine. I mean, you can use whatever you'd like, right? And then they are doing some further checks. So again, you don't have to follow these steps. They are very, very specific to the project. But I just want to show you how this project is doing it. So maybe you are inspired a little bit and you can build really awesome stuff for your own projects. And what I want to talk about also that is very, very important, that a CI tool provides, is having the ability to build on different platforms. And as you can see here, one of the jobs is building on Windows. And this is what's cool about GitHub Actions, is that you don't have to use Ubuntu as your runner base, right? You can use Windows machines. You can even use Mac OS machines. This allows you to build and test your program or whatever you're building on different operating systems. And this is how you gain extra confidence of the features you are trying to introduce. Same steps over here. Obviously, the build steps for Windows are going to be different. So they have a batch file created, and here they are displaying some build information, and then they are running the tests on Windows, right? And obviously, the Windows tests are going to be completely different from the Linux tests. They are doing the same thing for Windows, but for 64-bit, I think, over here, and this is for 32-bit, right? I think we can see it obviously here by the x86 and x64 over here. So, and then the next step is to build for Mac OS. You don't obviously need to build for all of these platforms. It really depends on what you are trying to support. And the build steps for Mac are obviously different than Windows, obviously different than Linux. And I think this is it when it comes to the build pipeline for the cPython project. If we look here, the remainder is running the tests and running tests with SSL enabled, or even, I don't know what this is, address sanitizer. I'm not really sure what's going on here, but I think the point was made, right? We have not seen the linting step anywhere. We have not seen code scanning or security scanning happen anywhere. Why? Because they might not necessarily be included in this file, right? So let's have a look at their workflows directory and check. Do they have a code scanning or security checks built in? I'm not really sure. It doesn't look like it. Maybe they are using a third-party tool for this, which is highly likely. So they could also have other CI tools running different types of tests, or even they have a direct integration between GitHub and a code scanning tool. That's also an option, right? Doesn't really matter what you use as long as you get the same outcomes. So this is how the cPython project does continuous integration. If we go to the Actions tab, let's make it a little bit bigger. If you go to the test workflow, you should be able to see that this workflow is running on different branches. It's running multiple times a day or even multiple times an hour. And some of them are succeeding, some of them are failing. All of this is totally natural. And I think I was mistaken because I can see here also a CodeQL workflow. It doesn't seem that it's actively used, but it seems that the team is experimenting maybe with CodeQL, because I only see here 2 workflow runs, which is not really indicative that they are actively using this. CodeQL is used obviously for code scanning and security scanning. You can see here that there are obviously other types of workflows. And these might be related to generating the documentation or maybe even creating the releases, right? So we're going to talk about some of these things when we cover continuous deployment and continuous delivery at a later point. We're going to start our demo with this basic repository. You can see here it's called CI/CD intro, and it exists in my profile. So it's public. You can go clone it, change it, modify it, create pull requests on it, do whatever you want. This repository is composed of 2 main things. Terraform code to set up and install 2 EC2 instances in AWS. We're not going to go through that right now. We're going to cover this in a later video when we talk about continuous deployment. However, we're going to talk about the web app that is created using Node.js and the Express framework. And as you can see, this is the typical Express folder structure. I don't have anything much going on here other than the regular package.json file, the app.js file, which contains the main logic, the routes folder, the tests, the views. Again, this is very vanilla boilerplate. There's not much going on here. I just modified the routes a little bit. I've added the users.js, and by default, the index.js comes in. You can see here that we have a couple of routes, the index route, and then we have the ice flakes route, just so that we can add something of a change. And here, this route responds with a very simple JSON object. In addition to this, you can see the .github/workflows folder. And in this folder, I have 3 files. The first file is the continuous deployment file. We're not going to talk about this now. That's for a future episode. Then we have the ci.yaml file, and then we have the CodeQL analysis.yaml file. We're going to talk about these 2 in the session today, the CI and the CodeQL analysis file. And we're going to start with the ci.yaml file to discuss what's in it. First of all, we have the continuous integration workflow. That's basically the name. And this workflow is only going to be triggered whenever we create a pull request on the main branch. That's how I want to do it. Obviously, you are free to change this behavior to whatever suits your application or suits your setup. For me, this will work for this app. And the second thing is I want to set up some defaults. I want to say that whatever the job, whatever the steps, I want it to use bash as a shell, and I want it to work within this working directory. You might ask, why is this necessary? Just because this is how I set up my workflow. These are parameters that are available for you to use them or not. They're not really strictly necessary for you to set up, but this is how I want to do it in this case.
And then we have the first job, right? So first of all, we need to run the tests. For me, there are a set of unit tests that I would like to run. So this is how we're gonna set up the first job, and it's gonna run on Ubuntu latest. And the steps are basically checking out the repository, doing an npm install, and then doing an npm run test. And what does the npm run test do? So if you go back a little bit to the, I'm gonna open it in a new tab. So if you go to the web package.json, you will see here that part of the scripts that I have, right, I have defined 3 entry points, and the entry points are start, which will basically run the bin www file, which, as I mentioned, will bootstrap the whole thing and will start the web server. There's linting, and I'm using the library standard.js that will do the linting as well as fixing the lint problems. This might not necessarily run the same way in the CI pipeline, because I don't want the CI pipeline to modify my code, right? This is very important. CI should not be introducing changes. CI should only be running tests and reporting back if there are problems. The developer will always be responsible for fixing these problems in the next iteration, right? And finally, I want to run the tests with Jest or Jest, whatever you want to call it, which is the unit testing framework I am using in this particular case. These are the 3 entry points, and I'm using one of them in the workflow right here, npm run test. And I encourage you also to do the same, right? So define your scripts in the package.json file, and then just simply call them with npm run test. That's if you're using npm. If you're using Yarn, obviously the Yarn has probably a similar feature, and it's slightly different than this one. Next, after the testing job, I want to run the lint job. And it doesn't really matter whether the lint runs before the tests or the tests run before the lint process. They're completely independent, and I don't really care if they run in parallel as well. So that's why I don't create any chaining or dependencies in between them. I just want to run them very freely. And I call this run linter. Also runs on Ubuntu latest, because I don't really care. I'm not deploying this application on any other operating system. So I'm also deploying it, as you will see later, in a Ubuntu environment. So this should be okay for me. And then the steps are, again, checking out the repository, and it's very important. That's part of the design for actions, right? You always have in every job to check out the code base if you want to run anything on that code base. What you need to understand is each job runs on a separate runner. So these jobs, as I mentioned in the first video, right, they run on runners. And these runners are basically either VMs, they could be pods in a Kubernetes cluster, they could be whatever you define them to be. But each job runs separately, right? So the test job, even though we checked out the repository here, this repository, once this job is completed, the runner is destroyed. The lint job will not run on the same runner. That's why we have to check out the code base again, right? It's very important to understand. And that's why it's part of the design. And this is important. Why? Because we want each job to run in a clean setup, right? We don't want the outcomes of one job to affect the outcomes of another job unintentionally. If we wanted to, we can design it that way. But here, I don't want them to be that way. So I'm going to keep them separate. We're going to do another npm install, and then we're going to run npx standard-v, which will basically output the linting problems or the coding style issues that it identifies in my project. Obviously, there's a little bit more that we can do here other than just testing and linting. There are a few tricks that we can utilize to optimize this workflow. So for example, one of these tricks is basically using caching, so that we can cache these dependencies to avoid having to download them every time we want to run the job, right? So we can, because if they're not really changing and if I'm not adding any new dependencies, why would I want to download them every time and just wait for it, right? I can download them once, cache them, and in every other future step, just use that cache to download these dependencies and make them available for my jobs. And a bunch of other tricks that we can cover in more advanced videos. And the last stage that I would like to cover, not in much detail today, but it's going to be very important for us later, is the deploy job. In continuous integration, you don't necessarily need to deploy automatically. This is very important. And when we talk about deployment here, I'm talking about a deployment to a staging environment. you never deploy to production in your continuous integration pipeline, because this is a pull request. This is not part of the main branch yet, right? If you remember here, we have triggered this workflow based on a pull request to the main branch. It's still not part of the main branch yet. This is just a test. Now, if you want to test in this case, because I might be working on this project with maybe 2 or 3 developers, so we don't really mind if every pull request deploys changes to staging and if the staging environment is continuously changing. That should be okay. In a big team, this is not good at all. Because then if you have 3 or 4 or 5 pull requests that come in sequence, then the staging environment will always be deploying the content of that pull request and you will be overriding the work of someone else. So this is not really good. What you would want to do is, instead of deploying to one environment, maybe what we would like to do is to set up a new environment, right? And then deploy to that one. And this is how staging or deploying to dev might work in a CI pipeline. Instead of deploying to just one EC2 instance, maybe we spin up an EC2 instance using Terraform for each time we have a new pull request. And I'm going to talk about this in more detail when we cover the Terraform and continuous deployment video. We're going to talk about how you can spin up a new environment in your CI, how you can deploy to that new environment, and how you can report back the information for that new environment, and how you can shut down that environment once your testing is completed and once the pull request has been merged. But for now, for simplicity's sake, I'm just going to utilize the environment that I have, and I'm going to say this deployment job requires the test and the linting jobs to be completed before we can deploy. And the steps are, we check out this repository, and then we use this action to SSH into that EC2 instance. And then we are simply doing a very simple rsync, right? And if you're not familiar with what rsync does, it simply just copies and makes sure that 2 folders are in sync. So it will basically copy the content from my runner onto my staging EC2 instance. And once we do that, I'm using this action also to SSH into the server and run a few shell commands, like starting the web application. And I'm using here a process management tool called PM2 because I want the app to be running indefinitely, right? And then I am restarting Nginx to pick up the changes. Again, this is all going to be covered in the continuous deployment and continuous delivery video. For now, let's just take my word for it. This is going to work. And let's just see it in action. And I think you're already familiar with my Ghost account from previous videos. You can see here I am signed in as LinkGhost, which is another GitHub account that I own. I'm going to go to the same repository because I want to introduce some changes and I want to show you how the CI process or CI workflow is going to run whenever I create a new pull request. And I'm going to do all of this from the UI because the changes I'm going to introduce are going to be very minimal. So I'm going to go to the README file, or maybe actually let's do a change on the web, on the application front. So maybe we go to the routes and then we go to the users.js and then we edit this file and we change this to get users. And then instead of just committing the change, I'm going to create a new branch, right? As well as a pull request. So I'm going to call this LinkGhost and I'm going to say update users routes. And then I'm going to commit the changes. And once this new branch has been created, a new pull request view is launched or is opened. And here I can say I'm updating the routes for the users.js file. And you can provide obviously as much details as possible about your pull request according to your best practices. And I'm just going to create the pull request over here. And once I do that, you will see that I already have 3 checks that are going to be running now to verify the changes that I've introduced, right? So we only changed one file. And now we're going to run the tests and all of the different, we're going to run the build, we're going to run the lint, and then we're going to run the unit tests to verify that our code works as it's supposed to, as well as the code scanning, right? So if we go to continuous integration workflow, we will see that we only have one job that is currently ongoing. And this job has been triggered by the link-ghost update users pull request. You can see here, pull request number 6. If I click on the update users, now it's asking me for approval to deploy to staging. Again, just ignore this for now. You can see here that the run unit tests as well as the run linter jobs have succeeded. They did not take much time, 20 seconds and 14 seconds respectively. If you go to the details of this, we checked out the repository, we installed the dependencies, and we ran the bogus unit tests. And you can see here that both of these tests have passed. We are in the clear. And if I go to the run linter, you will see here in the run linter job that I don't have any issues with my change. And if I go to the pull request view right now, I will be able to see that the run unit tests as well as the run linter job have been successful. However, the code scanning is still in progress, and I'm going to describe this a little bit now, as well as the deploy staging is waiting. What is it waiting for? It's still waiting for my approval, and we're going to talk about gated deployments in a future video, right? So code scanning seems to have been fixed right now, and it seems that it did not pick up any problems from my code. So if I want more details, I can click on the details button right here, and I can see that the code scanning has ran on my branches, and it really did not find any problems or alerts, which means that my code seems to be secure, at least as secure as whatever exists in the GitHub, as well as a bunch of other security advisories. Now, in order for all of this to work, I need to establish something called branch protection. And if I jump to my other account right now, if you can see here, I am logged into Link because Link is the administrator for this repository. If I go to the settings page, and if I go to branches over here, you will see that I have something called branch protection rules, and I have enabled them on the main branch. And if I go to the edit button over here, the first rule I have enabled is that each pull request will require at least one approval before merging it. And I have also enforced a number of status checks to happen, right, before I am able to merge the pull request. How do I specify these status checks? Basically, it's very important for you to understand that the workflow that I've created, the CI workflow, right, it had 2 jobs or 3 jobs. It had testing, linting, and then deploy to staging. We also had the CodeQL analysis workflow, right? In order for me to specify that I want these checks to pass before the pull request can be merged, all I have to do here is to enter the name of the job, right? And the name of the job in this case is lint, so it will highlight it for me right here, and I can click on it and it will become part of the list of the checks that are required before the pull request can be merged. Now, a common mistake that people do here is that they enter the sometimes they try with the YAML file name. That will not work. So if you enter CI here, it will not be able to pick it up. If you also enter the name of the workflow, like continuous integration workflow, that will not work, right? So you don't do it on the level of the workflow, you do it on the level of the job, right? So if you enter, for example, here, test, you will see that it will pick it up and it will suggest the run unit tests. Now, once you have branch protection set up, I think the rest is pretty clear. If we go back to the Actions tab, I want to show you the code scanning part. Code scanning is part of something we call GitHub Advanced Security. It is available for all public repositories, and I highly recommend that you use it. Right? Code scanning is amazing because it will basically scan your code base for vulnerabilities as they have been reported in the security advisories, and it will give you recommendations on how you can fix them. There is really no reason whatsoever why you should not enable code scanning on your repositories. And the way you would do that is by creating a new workflow, and you can call it whatever you'd like. This is a template workflow that comes from the sample workflows that we provide. So there's not really much that I have changed over here, except that I think I left these to the default. So this workflow will run whenever you push to the main branch or whenever you create a pull request on the main branch. It will run on Ubuntu latest. Here we are providing the permissions to the GitHub token that is available by default for all the workflows. We are just specifying which permissions this token is granted for this workflow whenever it runs. And we are defining the strategy here. Something I did not mention in the first video or this one is that you can have a matrix. You can adopt the matrix strategy, and you can have matrix workflow runs. And the matrix workflow run, I'm going to talk about it in future videos. But in short, or the LDR, is that you can here define multiple values in this array, and the same job will run for each one of these values. And the value here will be taken as a variable that you can integrate in your test. So for example, you can say, I want to run this job for Ubuntu, Windows, Mac OS, and I also want to run it on Ubuntu 16, 18, and 21. You can have all of these things in a matrix array, and then the same job will run on each one of these environments in parallel. Now, the steps here are, again, very basic. We check out the repository, and then we use the CodeQL action to initialize with the matrix language that you have defined here, which is JavaScript, as you can see. So this will be replaced with the value JavaScript. And then we are telling CodeQL to auto-build the project. And this is the really cool part about CodeQL, is that it will identify what type of project we are trying to run, and it will attempt to build it for you, right? So if it's C++, C, C#, or Java, it will try to build the project for you. And once that is done, it will run the analysis step on your code, and it will try to identify if there are any problems or vulnerabilities with it, and it will report them back. So this is how CodeQL works. It's very simple. You can just copy this exact same workflow and put it in your projects, and you should be getting some interesting results, especially if you have a more advanced project than my simple example here. Now, the last test in this demo is for us to just approve the pull request and merge it. So we're gonna jump to the other account very quickly, and I'm gonna go to the pull request, and I'm gonna request a review from link, and I'm gonna jump to my other profile, and as you can see here, I have a request to do a review for this pull request. I'm gonna add my review right here. I'm gonna say everything looks great, ship it, right? And I'm gonna submit my review, and once I do that, you will see here that the squash and merge button and everything else is green. And now all we need to do is just to press this button and confirm the squash and merge. And this is it. The branch is automatically deleted because I set it up to do that way. And if we go to the code, you will see that my pull request has been merged. So if we go to routes, users, you will see that our change is now part of the main branch. This is everything I wanted to share with you regarding continuous integration for now. If you found this material useful and you want to be notified whenever I release the future videos in this course, hit that subscribe button. Next time, we're going to be covering continuous delivery and deployment in the same manner as we did with continuous integration today, and I'm gonna bring you real life examples so that we can all learn from them. Thank you for watching, and until next time.